I'm going to explain about circuit level measures to reduce power consumption while designing a chip. So final aim for the VLSI chip is to reduce the power consumption so that it can increase the reliability. Instead of using, it may be, for example, your mobile may be right now you are getting only 2 years. After 2 years it may not work, but by using these techniques you can increase from 2 years to your lifetime of mobile. So can increase from 2 years to 5 years reliability. 5 years with this technology. If you are using these techniques, the companies, all other the chip designing companies can increase the reliability of your mobile, reliability of your laptop, reliability of other chips like that. So these are the benefit, that is lower dynamic power and better speed of your processor or laptop or mobile, and improved overall circuit efficiency. So these are the advantages if you are follow some techniques. That is unnecessary. We are using different techniques while designing your laptop or mobile. So I'm assuming here this is your laptop. Assuming this is your laptop, so internally it is having RAM, random access memory. Of course it requires ROM, and it requires memory card, it requires ALU, and everything is there internally. So this is a processor. So here, what technologies at the circuit level, what technologies you are using to reduce the power consumption? So here I can say this: pass transistor logic at the circuit level. We are using that is pass transistor logic. Here you can say this pass transistor logic you are using, and transmission gate logic you are using, clock gatings you are using. So without clock gating we can use, it consumes more power without clock gating. If you are used, that is clock gating, you can reduce the power consumption. When it is not required, you can stop the clock, and enable should be 0. When you are using the pass transistor logic, you can easily drive the data from one side to another side. And unnecessary transitions, actually we need to get the input from 1 to input is 1, output is 1, but in between unnecessary transistors will get because of glitches and other logic fail. So you may get that is 1 to 0 and 0 to 1 transition, again 1 to 0 and 0 to 1 transitions will get. So this can be reduced. And that is optimization of gate. So initial days, that is they are using, that is just assume while nanometer technology, 180 nanometer technology they are using, and then these are the approximate technologies. 90 nanometer technology they are used, and 45 nanometer technologies they have used, and 22 nanometer technology, and 11 nanometer. Now at in 2026, that is 4 nanometer technology they are using to design any chips in real time. So of course we can optimize the size of the transistor. So and different algorithms are, that is logic style optimization, as well as that is multiple threshold voltage technologies are using to reduce the power consumption. And logic optimizations also can use, and we can optimize the logic so that it can reduce the power consumption. And clock gating, this is without clock gating, may consume more power, but while using clock gating we can reduce when it is not required, so that it can reduce the power consumption. So like that, not only this, they are using, that is MTSO technology, that is MT CMOS technology, and MT VT CMOS technology to reduce the power consumption, and also they are using, that is, parallel processing and pipelining, as well as to reduce the power consumption, to increase the speed of the your mobile. So we can say this here, the same thing, that is to increase the speed of your processor, your laptop. So here low swing circuits or else transistor sizing we can optimize, and they are using, that is, multiple threshold CMOS circuits and variable threshold CMOS circuits they can use, and transistor stacking and logic we can used, that is optimized logics and pass transistor logics you can use. So these are the techniques to reduce the power consumption and increase the speed of your laptop or mobile or any other chips while designing a VLSI chip. Thank you.